Hello friends, the Bourbon Nerd here. Welcome to lesson 12 in my bourbon school. So today I'm going to cover the very fascinating topic of how alcohol proof and ABV can change over the time it's being aged in the barrels. And to help me through this episode, I am sipping on one of the old versions of the Elijah Craig Barrel Proof. So this is 139.4, so I think it's appropriate for the topic of this lesson here. So it's very, very close to what is referred to as hazmat. If you don't know, hazmat is short for hazardous material. And I don't know if you know this detail. So if a whiskey is above 140, so that's the level of hazardous material, not only can you obviously not have it into your carry-on luggage, of course, but you cannot even have it into the checked-in luggage on the flight. So this is a close one here. So I'm just gonna sip on this. I'm gonna cry when this bottle is empty, but it soon is. So cheers, y'all. Whew. Oh, nice. All right. So on to the topic of today. So what do you actually think happens when the whiskey ages in the barrels? What about the proof level of the whiskey? Does it stay the same, or does it go down, or does it go up, right? So the good thing is, in a few minutes when this lesson is over, you will know exactly what's going on, and I will cover a couple of the top 5 reasons why there are changes. So I'm going to give away a little bit. It will change, and I'll explain why it can potentially go up and go down. So I'm returning to an old image. If you follow my previous lessons, you've seen this a couple of times before. Actually, in the previous lesson where I covered Angel's Year, it's basically the evaporation during the summer period, or when the barrels are being aged. And as you can see in the picture, the whiskey has tried to sort of penetrate the wood on the oak barrels here, and it sort of gets out. So there's natural evaporation all the time the barrels have been aged, right? And when we talk about evaporation, let's actually examine water versus alcohol, ethanol in reality, right? So basically that's what whiskey consists of. Initially it's water and ethanol primarily, right? And as you may recall from school, water obviously boils at 212 Fahrenheit, 100 Celsius. So it starts to evaporate at that level. Ethanol, C2H6O, is a little lower. It actually evaporates around 173 Fahrenheit, which is about 78 Celsius. So alcohol, so ethanol, actually evaporates faster, sooner than water, right? So every logic points to the fact that, of course, as the barrels age and natural evaporation is starting, the alcohol level will be lower and lower and lower, because obviously alcohol evaporates before the water, right? But then have a look at these two labels here. So if you recall from, I think, lesson 2 or 3, the maximum allowable proof level from when the whiskey has been produced and when it goes into the barrel is 125 or 62.5 ABV, right? And as you can see on these two labels here to my left, they're actually 147 and 148 proof. So how is this possible, right? So on these two whiskeys here, the proof level have actually increased with time, even though we just examined that sort of alcohol evaporates before water. And again, I'm going to return to this fascinating image here, because it's an image of an oak stave, of course. And oak, especially American white oak, is so fascinating because the molecule structure in American white oak is so dense. Even the place where sort of the staves go together, because they're obviously connected by metal hoops. So it's very, very, very good at containing the liquid here. And that is one of the 2 main reasons why the proof level changed that I'm going to talk about today. So let's look at water and ethanol again, right? So you can see here's actually a picture of how the molecules look like. And as you can see, of course, the water molecule is much smaller than the ethanol molecule. And believe it or not, that is one of the reasons why, despite the fact that alcohol evaporates before water, it's because the ethanol molecules are larger than the water molecules. So it's much easier for the water molecule to sort of penetrate the wood, if that makes sense. So it's sort of contrary what you would think would be reasonable to think. So in this case, that is one of the probably top 2 reasons why the alcohol can actually increase in proof during maturation. And that is simply because the water has easier way to escape the barrel compared to the ethanol. So that was one of the really fascinating things that I discovered once I dug into the topic of whiskey many years ago. So, okay. So, but then of course, so we established that the proof increases, right? Because the water molecules are small, right? But then look at these 2 images right here, especially the fascinating one at my far left here. So this is, as you can see, an Old Scout. It's a single barrel, but if you look closer, this is a cask strength product, which means that it has not been diluted with any water, right? And not only that, it's spent, as it says here, 11 years in the barrel, and yet this is 48% ABV or 96 proof, right? So it has considerably lower than when it originally was put into the barrel. I'm guessing that the proof level on this one, so it's right now 96, 97. My guess is that when it was put into the barrel, it was anything between 115, maybe 110, and 125, which is the more plausible case. So this whiskey has actually decreased in proof. And the same goes to the Maker's Mark next to me. I know the Maker's Mark here went into the barrel at 110. So of course, not a big change because it's 109, but still yet it has actually decreased. So what on earth is going on? So we just established that it actually increases because of the molecule sizes. And that leads me into the second reason why there could be changes in the alcohol content during maturation. So I have here a picture of a barrel warehouse. It's also called a rick house. And as you can see on the picture, this is pretty much the same for a lot of the larger warehouses out there. So the barrels are sort of stocked in different floors. Typically, there are like 3 barrels on each floor. And some of the warehouses, unlike the one on the picture here, actually do have real floors where you need to take staircase from floor to floor, right? And the higher the barrel is in the warehouse, of course, the hotter it will be because for temperature and heat rises, and it also becomes less moist. It's also drier in the top there. And if you look at the bottom layer of the warehouse there, then the barrels are colder. It's a colder climate down there, but there's also more moisture there. So that is a reason why some barrels can actually decrease in proof, because not only is it colder down there, some of the evaporation from the barrels on top of them, I hope this makes sense, can actually drip down on the barrels themselves and then being absorbed by the oak and then actually mingling again with the whiskey inside the barrel. Very fascinating. And you know, from the picture you saw before from the Old Scout, this has been, I'm guessing it's been very, very low in a barrel house, maybe even on level number 1, and been in a sort of like a colder area, and maybe also in a special type of rick house, which I'm going to cover in just one second. So this is sort of like the other reason why alcohol levels can go up and down. So one thing is the molecule size, but also the higher in the rick house, the more evaporation and the higher the proof will be, and the reverse is in the bottom of the warehouse itself. So I sort of summarized the main reasons on the next chart here, because there are more reasons than this, but I just want to sort of give you a little bit of an update here on what causes the changes here. So if you look at the things that increase and decrease here. So ironically, time is on both sides of the chart here. So as time goes on, of course, it starts at the same time, but as time goes on, it can both increase or decrease depending on the other factors that you can see below here. As I explained, you know, a very, very hot climate will naturally increase the proof because of the evaporation and the small molecules. That means, for instance, if you compare Texas, to take an extreme, with Scotland, as time goes on, the proof level will increase considerably in the hot Texas climate, whereas in the very, very cold and very moist and rainy climate in Scotland, it will actually decrease. I hope that makes sense. Also, as I just explained, the high floor storage will actually increase the proof, whereas of course a low floor storage will do the reverse. And then there's another thing which I also found interesting, because most of the warehouses out there are made either from metal or from a combination of metal and wood, the warehouses themselves or the rig houses themselves. And especially when there's metal on the roofing and even on the sides there, it becomes super, super hot in the summer. That helps, of course, make the whiskey better, because the whiskey penetrates the wood when it gets hot. So we like that. But it also, of course, results in increased angel share and evaporation, which is why the proof tends to increase faster in warehouses or rig houses that are made from metal. There are also some places where the warehouses and rig houses are made from brick, famously so, for instance, MGP in Indiana, who is the source of many whiskeys out there. And when the warehouses are made from brick, if you live in a brick house yourself, you know it's getting cooler in the summer compared to if you had, for instance, a tree house or a house made from metal or otherwise, because it sort of protects, it sort of insulates better with the brick. And many of the MGP warehouses are made from brick, so that actually causes whiskey age in MGP warehouses, where I'm guessing the old Scout image that I showed before is actually where it comes from. That actually decreases the proof because it generates a lot of moisture also internally. And then finally, sort of like a sum of this, the humidity, which is sort of like the second case the second cause that I explained about before. Very low humidity, either because of the climate or because of the level on the rig house where the barrel sits, will increase the proof, whereas high humidity, either because of the geographical location or because of the placement in the warehouse, will cause the proof level to decrease. So, well, basically there you have it. Very, very fascinating. You would think, at least I thought, that alcohol will go down and down and down with aging because alcohol evaporates before water, but it is not always the case. And generally, for most bourbons out there, since 95% of all bourbon is made in Kentucky, and Kentucky has a very, very high hot climate in summer, and most of the warehouses are made from metal or wood, an average Kentucky straight bourbon or whatever, it will increase and increase and increase the proof over time. Of course, the manufacturer may decide to dilute it down to whatever level they want to do, but if you have a cask strength bourbon that has just been sitting there in a high level warehouse in the hot summer, it can approach these insane 140, 150, 160 is the highest I've ever seen in a commercially available product, and that's almost jet fuel, right? So there it is. I hope you enjoyed this very short lesson and hope to see you again soon. Cheers.